lesson. This is Algebra lesson 8.6, quadratic equations. These are perfect squares. Just like the last time, you're looking for the pattern. Okay, you're looking for a pattern here. Notice this. Here's what I'm talking about. If I have this, a plus b, and I square it. Are you all watching this? This is, it's up to you. You don't have to. If I have this guy right here, okay, and that means that it's going to end up looking like this. That's the same thing as a plus b times a plus b. Do you agree? Do you agree? Same thing? Okay. Which means that when I actually go and do it the long way, when I FOIL it, it comes out to a squared plus 2ab plus b squared. That is what it means. Okay? That is what this is. Like this and this are the same. One is written with the square, written this way. The other one has already been, this one is factored, and this one is not. Okay? I'll say that again. This guy is not factored. This guy is. Right? If I was to give you anything, if I gave you x squared plus 4x plus 4, and I said factor that, what's it going to look like? What will it look like, people, if I said to factor this? What would it look like? It would look like, right? It would be two binomials multiplied by each other. If I gave you this and said a squared plus 2ab plus b squared, if I could factor that, what is it going to look like? I'm sorry. If I could factor that, what's it going to look like? Two binomials squared, right? So then if there's this guy here, when you factor it, right? When you factor this guy, it's going to look like that. A plus b times a plus b, right? But since they're an identical number, we can just go a plus b squared, because that's the same thing as this, right? Are we all following this? So I'm going to put it up here again. A plus b squared is the same as a squared plus 2ab plus b squared. Like I said, if I was to take the time here to go a plus b times a plus b, do you know what it turns out to look exactly like? Can you point? What does it turn out to look exactly like? Right? It's that. Yes? So, what you need to be able to do is tell when this guy here is a perfect square trinomial. It will make your life easy. It just will. Yes, there are other methods that you can use to factor this. There really is. Obviously, you know this. You've done it before when you do the grouping and the big long process of grouping. That's fine. But wouldn't it be easier if you could look at something and go, oh my goodness, it's just this. Right? So that's why we do this. Let me give you one. Let me show you what I'm talking about. If I have, what if I have this 16x squared plus 24x plus 9? Now I want you to pay attention. I want you to look up here. If I asked you to factor that, what's the first thing you're going to do? See if you can pull something out. Is there something I can pull out? Is there an x in each one of these? No. Is there any number other than 1 that I can pull out of each one of those? No. So then at this point, what is your options? Before I taught you this today, before we get to this today, what was your option? We've done this in the past. What can I do? I just mentioned it to you. What could you do? You could group them, right? To group them, you'd go, okay, 16 times 9, whatever that is. You're going to find the factors of that. Okay, what is 16 times 9? Anybody know? Well, how can you do that very quickly? What is 16 times 10? 160. So it'd be 16 less than 160, right? So 144. So it's 144 Oh my goodness, do you want me to write down the factors of 144? Oh boy, okay. 1 and 144. 2 and, do I make my point that, do you really want to do this? I'm serious. Do you really want to write down all the factors of 144? Because what if you forget one set of factors? That could be the end of your, so do you really want to do that? No. What you want to do is you want to recognize this. Recognize this. Okay? On page 505, look in the middle of the page. On page 505, look in the middle of the page where I wrote this same thing down. What you want to do is look, is this first term a perfect square? Is that a perfect square? Yeah. Yes. Okay. Is the last number a perfect square? Yeah. Okay. Now, here's the one that's really tricky. Is this number here, 24x, is that the same as, okay, first of all, what is the square root of 16x squared? 4x. What is the square root of 9? 3. What this number needs to be, if it's a perfect square trinomial, is that number will be 2 times 4x times 3. If this number here is 2 times the square root of this and 2 times the square root of that, then you're in good shape. What is 2 times 4x? 8x. What is 8x times 3? There it is. That tells you that this thing is a perfect square trinomial, which means that all I need to do is, look right here. It's 4x and 3, so it would be 4x plus 3 times 4x plus 3. Or you could write, what could I write instead of that? 4x plus 3 squared. Does that make sense? It's always good to just check that quick, because if it does work, then you can be done in 2 seconds rather than just spend the whole time. We would still be working on trying to find the factors of 144 right now. Let me give you another one. Here's this. 4y squared plus 12y plus 9. I'm going to show you one more, and then I'm going to let you do one. I'm going to show it to you again so you know the pattern. The first thing you do, all I'm going to say on your test is factor. First thing you're going to do is look to see if I can pull something out. Is there something I can pull out of all 3 of those terms? No. There's no variable, and there's no number other than 1 that I can pull out. Okay? The next thing I'm going to do is check to see, is this some sort of a special trinomial? In other words, is this a difference of squares? Clearly not, right? Is this possibly a perfect square trinomial? Well, let's find out. This is how you find out. You look at this thing and you see, is that a perfect square? Is 4y squared a perfect square? Yes. What is that thing square rooted? 2y. Is 9 a perfect square? Yes, that thing is a 3. Do you agree? So we're 2/3 of the way there. The last one has to also be true. This guy needs to be 2y. It needs to be 2 times 2y times 3 is 2. What is 2 times 2y? 4y. What is 4y times 3? 12y. Is that true? Is it 2 times this times this? Yes. Therefore, we know this whole thing is, what is it called? A perfect square trinomial. Here's the deal. Now that we know that, look what you do. You take this, and you go 2y plus 3 squared, and we're done. It's that simple. That's all you do. It's really simple when it works. If it doesn't work, you go, oh, okay. Now I have to go back and do my other thing. I have to group them and see if I can factor something out of there. Let me give you one to try. Try 9y squared plus 24y plus 16. And I'm going to ask you to factor this. So here's the deal. I say factor this. You go, can I pull something out of there? Is there something I can pull out? What can I pull out? I can't pull out a 3y. What can I pull out? Nothing. First thing I do is look at, can I pull something out? No, I can't pull anything out, right? Then you look and go, okay, is that a perfect square? Yes. Is that a perfect square? Yes. Is 24y, is it equal to 2 times, what's the square root of 9y squared? 2 times 3y. And what is 16? What's the square of 16? Times 4. What is 2 times 3y? 6y. What is 6y times 4? 24y. That makes this true. That means that this whole thing is, what is 9y squared square rooted? What is 16 square rooted? Make sense?
What happened if it's not true?
Okay, that's a good question. Here's the next one. Try this one. 2a squared plus 10a plus 25. Is that a perfect square trinomial? Why not? Isn't 25 a perfect square? Yeah. What about, is 2a squared a perfect square? No. What number times itself is 2? Oh, so then it's not a perfect square trinomial. Does that mean you can't factor this? No. In fact, how would you factor this? Let's be reminded. How would I do this then? So let's go through the steps. You first look at this thing and you go, okay, this is, can I pull something out? No. Okay, I can't pull out a 2, nothing. Okay. You look here and go, is that a perfect square? No. Okay, so then we know it's not a perfect square trinomial. Okay. Now we go, okay, now we have to go 2 times 25 is 50. Okay, what is the factors of 50? 1, 2, 4, no, not 4. 1, 2, 5, 10, 25, and 50, right? Which means that I'm going to pull these things apart. I'm going to bring this down, and I'm going to go, okay, 2a squared. And I'm going to pull it apart to which of these numbers which of these numbers will add up to 10? Which of these two numbers, which of these two groups will add up to 10? Oh, there's none, right? There's nothing. So then what do I do? What is the answer? It's prime. There's nothing to take out of it. Does that make sense? But you had to go through that whole process to know that it was prime. Yes?
What if it's like, it's like
Number what?
like a number 29 is like 2a squared,
Where? Number 21?
like number 29, what would you do?
Well, you can pull out a 2 and an a across the whole thing, right? So that would be the beginning, and then you kind of see where it lands. And you know how you just go through the steps, Now, something else. Sometimes they're minuses. I'll show you. Give me a second. Where's a minus one? Okay, try this one. Nothing changes. Try that one. So you're watching. First thing you look for, can I pull something out? No. Next thing you look for is you want to know if this is a special kind of trinomial. Is that a perfect square? Is that a perfect square? Oh, it is, right? 9's a perfect square. So then, I now need to see if this is exactly 2 times, right? So let's take a look. What is this thing squared? X times, so that would be 2 times x. What am I doing? Is that right? 2 times, 2 times x times 3. What is 2 times x times 3? It is 6x. Now here's the deal. You know how I went up here and when I circled this, I grabbed that negative sign? Didn't need to grab that. What I'm looking for is not that it grabs that it equals to that. That negative sign, so that's true. It does equal 6x. Do you agree? Okay. So then because of that minus, let's see what we can do. What about x minus 3 times x minus 3? Because it's going to multiply to a positive, but add to a negative, right? That works. X minus 3 squared. Make sense? Does that make sense? This one up here, the one I just gave you, the x squared minus 6x plus 9, was the first lesson in this chapter, right, where you just go, okay, that's what multiplies to 9, it adds to negative 6. And negative 3 and negative 3, right? Does that make sense? Okay. We will be practicing this more. Let me get you, I still have 10 minutes. Try this. 2x squared minus 32. No, we've done this. Hold on. Wait. 12x squared plus 5x minus 25. Brutal. Okay, I'll be impressed if you can get it. First thing we do, listen, you have to go through the steps that you already know how to do it. Is there something I can pull out of this? No. So pay attention. Muna, up here. I want you up here now. For real. Nothing I can pull out of this, okay? Now we're going to go see if it's a perfect square trinomial. Is 12x squared a perfect square? No. Okay, so that doesn't work. So now we have to go back to our old bread and butter, the old way of that we know how to do this, is you got to find 12 times 25, which is 300. I have to find the factors of 300. If there was no 12 there and it was just an x squared, what would I do?
I would just keep 25.
Now you just go, okay, what multiplies to 25 or negative 25 and adds to 5? Does that make sense? Okay, but if there's a 12 there, so we find the factors of whatever this times this is. 300. Oh my goodness. 1, 2, 3, 4, 5, 6. It's a mess. Doesn't change the fact that I could easily give you this. This is simply this is one of the sample questions. So you have to be able to do this. 6. Oh boy. 10. What? 15. 20. 30. Do you know what I'm looking for here? What am I looking for? I'm looking for something that multiplies to a negative. So what does that tell you? One's a positive, one's a negative, right? Multiplies to a negative, but adds to a positive. So it's going to need to be two numbers that are within how much? 5 of each other, right? It has to add to a positive 5, right? So then what? Look here, 15 and 20. Guess what 15 times 20 is? 300. There it is. 15 and 20. Oh my goodness, so simple. So 15 and 20 are my numbers. So I'm going to go like this. No, not that. I'm going to bring this down. 12x squared and negative 25. And I'm going to split the 5 into 15 and 20. Which one should I put where? Should I put 15 first and 20 second or 20 first and 15 second? I don't know that it matters. 15 first. So plus, is it plus 15 or plus 20? It's got to be minus 15x. And plus 20x. Now, why does it have to be this? Why plus 20? Why can't I switch them around? They have to add up to a positive 5. Does that make sense? Okay. So here now I'm going to group them. What can I pull out of the first one? Pull out a 3x. That leaves me with 4x minus 5. Right? No, it's 4x. Right? And then over here, what can I pull out? Plus, I can pull out a 5, which leaves me with 4x minus 5. Oh, that's beautiful. Pull out, what can I pull out now? Pull out 4x minus 5. 4x minus 5. That times 3x plus 5. And we're done. Is it really that hard? Is that so difficult that you guys are beyond it? No. If you're going to be lazy, you're right. You have no chance. And I'm telling you, this is algebra. If you guys can't do this, you can't go on and do algebra 2. You can't, you have to be able to do this. going to give you one more. Oh, something else you have to know is this. What if I gave you a question that looks like this? Okay, we've done these types of equations before. This is an equation, agreed? Line down the equal sign. What do I do about this? Y minus 6 squared. What can I do to... I need to get the variable alone. He is so far from alone, it's ridiculous. Right? He's being square rooted. He's got a minus 6 here. So what can I do? What about this? What about square rooting that whole side and square rooting this whole side? What is y minus 6 squared, square rooted? What number times itself equals y minus 6 squared? Just y minus 6, right? Because y minus 6 times y minus 6 would be y. So now it's just y minus 6. What is the square root of 81? Wrong. What is it? What does it say? Square root of 81. See what your calculator says. What does it say? Wrong. Come on in. It's important that you understand the concept that you cannot just trust a calculator. It's very important because the square root of 81. I have a question. What is negative 9 times negative 9? Oh, so the square root of 81 could be 9, but it could also be negative 9, right? The square root of any number is not just the positive number of that. It's the positive or negative number of that. So you would put down it's plus or minus 9 because the answer could be negative 9. Don't you agree? Yeah. Isn't that true? Okay, well then, so now we have two possible answers here. So I have to solve it for both. So I have y minus 6 equals 9, and I have y minus 6 equals negative 9. Whatever I come up with, both. Now my answer is both of those numbers. Does that make sense? Okay. I have to give you something for homework. I'm going to give you, we'll make it real easy today. I'm going to give you 1 through 8 all. Okay? 1 through 8 all. Yes, I'm aware this will be difficult for some of you. We're going to go over this again next time. But this is your homework. I am taking this as a grade. Half of them you can look in the back of the book to see what the answers are. The other half you can't, but you do need to give it your best go. I'm taking a grade on this. You don't need it. You guys can go. If you have a detention for any reason, you have to do it today. Walking in here for detention and think it's in any way acceptable to talk, think again. This is detention. Come in, get your sets done, and go. Go. need detention. You walk in here again and you talk, I'm going to give you another day of detention. This should not be fun. This is jail, people. This is you being in trouble. Don't come in here loud. Get your stuff done.